Welcome back to Low Stress Math with Mrs. Bono. We're going to go over the review for Test 2, Marking Period 1, Solving Equations. So the first direction says simplify the following expressions. And when you look at the expressions, you see there's no equal signs. You cannot solve these problems. But what you can do is combine like terms and do some distribution. So that's what we're going to do. The two things we need to do, combine like terms and distribute. So what are like terms? Like terms have the same variable and the same exponent. So with this first problem, I'm looking at 1a right here squared. Now there's only one of them, that's why I wrote 1a squared. So this, and this is not a like term, but this is. And I'm going to take the sign in front of the number, minus 4a squared, minus 4a squared. Then the other like terms, plus 7a and minus 3a. Plus 7a is not the same as a squared. The square is a exponent, that's what makes them different. So I'm going to combine these two terms. 7a minus 3a is 4a. And I'm going to combine these terms. 1 minus 4, negative 3a squared. And there's a plus symbol there. This is a positive number, so plus. So my actual answer for this is negative 3a squared plus 4a. And there's my answer. For the next one, this minus sign is actually negative 1 times k minus 3. So negative 1 times k is negative 1k. Negative 1 times negative 3. Negative times negative is positive 3. And I don't need this 1 in front of the k. So I could just write negative k plus 3. Put a little box around it because it's done. Now I'm looking at that k there, and that doesn't look very k-ish. So I am going to fix it and make it look like a k. You want your letters to look clearly like letters and your numbers to look clearly like numbers. You don't want any old people with bad eyes marking you wrong. So again, with this one, like terms, I have 5p, and the subtraction sign goes with the 3p. So minus 3p, and the other number, minus 16, so I combine like terms. 5p minus 3p, 2p minus 16. Because 16 doesn't have a friend. We're just going to leave it like that. All right. Now this one has two parts. You have to do the distribution first, and then you have to go back and combine the like terms. So this is negative 2. You take the sign in front of the number. I know it's minus 2, but we're going to treat it like a negative 2. So negative 2 times g and negative 2 times 6. Nothing happened to the 4g. It stays 4g. Negative 2 times g is negative 2g, or minus 2g. Now, negative 2 times plus 6, negative 6. And nothing happens to the plus 10. I'm just going to write plus 10. Now, let's combine the like terms. Negative 6 plus 10 is 4, and 4 minus 2 is 2g. Is this a positive number or a negative number? Well, that's negative and that's positive. This one's bigger. Take the sign of the larger number, plus, and that's going to be 2g plus 4. The next thing is directions. Let's read through those. Review how to solve all types of equations. the distributive property, collecting like terms, fractions by finding the LCD, decimals, variables on both sides, and word problems. Identify whether the equation has one solution, no solution, or infinitely many solutions after solving. Okay, so let's try this. Now, I'm going to draw a line through my equal signs on all of them because I'm looking to see if there's variables on both sides. If there's variables on both sides, you have to do the inverse to move it to the opposite side. This only has variables on one side. That's good. This has variables on both sides and distribution. There's a lot going on in that problem. This has variables on both sides and distribution. Lots going on in that problem. So let's go back up to this first problem. Variables on both sides. This is a positive 2x. The inverse is minus 2x. So I'm going to subtract 2x from both sides. Let's see. 8x minus 2x is 6x plus 10 equals, oh, look at that, I forgot to write the plus sign. I'm going to make a little tiny plus sign in there. Plus 10 equals negative 14. The minus sign makes the 14 negative. The opposite of plus 10 is minus 10. So I'm going to minus 10 from both sides. And 6x plus 10 minus 10, these become 0. And I get 6x by itself equals negative 14 minus 10 is negative 24. I'm going to go back, and I am going to divide both sides by 6. That's going to be 1, and I get x equals negative 4. Put a little box around it because it's a gift. And now, how many answers do I have? I have one solution. Sometimes I write one unique solution, but it's basically the same. I'm just going to go with one. All right, so for the next one, I have a fraction. There's a bunch of ways to do these problems. Just relax. I'm going to multiply everything times the LCD 2. So my least common denominator is 2. I'm going to multiply 2 times 3 over 2, and I get 3k. And 2 times minus 9 is minus 18. And 2 times negative 24 is negative 48. Okay. Made it a lot easier to solve, and now it's just a two-step equation. I'm going to add 18 to both sides. And I get 3k equals negative 30. I'm going to divide both sides by 3 and get k equals negative 10. And again, that is one solution. Only one solution. K equals 10, that's negative 10. Oof, one solution. Okay, move that up a little bit. Give myself some room to work. You know I like that. And now I'm going to move some things around. I have 6x minus 10x plus 4 equals, now I'm going to take this negative sign, negative 4 times x, and negative 4 times negative 3. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Be careful. All right, 6 minus 10x is negative 4x plus 4 equals negative 4x plus 12. All right, I need to get the x's together, so I'm going to add 4x to both sides. Let's see. Positive 4x and negative 4x is 0. Positive 4x and negative 4x is 0. What's left is 4 equals 12. That's not true. 4 is not equal to 12. None of this is true. None of these are equal. For this, there is no solution. So when you get down to the bottom and you've eliminated the variable and the numbers are not equal, there is no solution. So for this one, let's take a look at it. I'm going to put a 1 here because that negative is -1. -1 times c is -1c. -1 times 15 minus 15 equals, nothing happened to the 2c, but now I'm going to take that minus sign and attach it to the 3 and make it -3 times c to get -3c, and -3 times 5 to get -15. Okay, I'm going to combine my like terms. Keep my -1c on this side, minus 15 equals 2c minus 3c is -1c minus 15. I'm going to add 1c to both sides. And you get -15 equals -15. Okay, I've eliminated my variable, and they're equal on the bottom. That means that there is infinitely many solutions. Because my answers are equal on the bottom. All right, now I'm going to write a little note to self, something to study for the test. So, for one unique solution, that has a letter equals a number, or a variable equals a number. I'm just going to write letter equals number. Whenever a letter equals a number, that's one solution. All right? Now, for no solution, that means you've eliminated the letter, so no letter. And number is not equal to number. And for infinite solutions, on the bottom you have no letter, and the numbers are equal. And look at me, I can't even write today. Number equals number. Now that's not the technical terms, but it's how I remember it, so I thought I'd share with you. All right. The next page, let's take a look. Of course, it's on the back. Why wouldn't it be? It's always so much more difficult on the back. Here we go. These are, again, a lot. There's a lot going on here, so let's just start with some distribution. We're going to do 3 times, wrong color, 3 times x to get 3x, and 3 times -4 to get -12. Nothing happens to the +6, or the equal sign, or the 5. And remember, that minus sign goes with this 5. And I'm going to distribute -5 to x and -5 to -1. Remember, the minus sign goes with the number right after it. So, 5, -5 times x, -5x. Negative times negative is +5. Okay, now I have to combine some like terms here. So on this side, I have like terms, -12 plus 6. So I now have 3x, -12 plus 6 is -6, equals, and on this side, I have 5 plus 5. So I have -5 plus 10. Oh, no, I don't. I have -5x plus 10. All right. Now I want to move the smaller variable to the larger, and -5 is smaller than 3. So I'm going to add 5x to both sides. and get 8x minus 6 equals 10. This is 0. 8x minus 6 equals 10. I'm going to add 6 to both sides and get 8x equals 16. Divide both sides by 8, and x equals 2. And again, that is one solution. For the next problem, I have a lot of fractions. I have 6 and 4 and 3. And the least common multiple there is going to be 12. 6 goes into 12 evenly, 4 goes into 12, and 3 goes into 12. So my LCD is 12, which means I got to multiply everybody times 12 and not be moving my papers all over the place. Here we go. 12 times 5/6 is 10. 12 times 3/4 is 12x. And 12 times 2/3 is minus 8. Let me double check that. 10 equals 12x minus 8. Okay, so I'm going to add 8 to both sides and get 18 equals 12x. Divide both sides by 12 and get x equals 3/2. Well, it's actually 3/2 equals x, but you know, I just flipped it around, which is again one solution. Or sometimes they say one unique solution. It means the same thing. All right, label the number of solutions for the following problems. That's what we've been doing all along. I know, we're just gonna keep going. So, again, here's my equal signs. I'm putting lines down my equal signs. And I have variables on both sides. So I'm going to subtract 2x from each side and get 2 minus 2 is 0. 2x minus 2x is 0. 2 equals 2. Oh, look, that checks. That means if the variable is eliminated and the numbers are equal, there are infinitely many solutions. Okay, so for this one, I have 5x on both sides. I'm going to subtract 5x. I'm going to subtract 5x. And I get negative 2 equals 4. That's not true. Negative 2 is not equal to 4. That is a darn lie. And when you have eliminated the variable, 5x minus 5x, 5x minus 5x, what's left? If they're not equal, that means there is no solution. Not equal, no solution. Underneath it, oh, I'm going to subtract 2x from both sides because 2 is smaller than 3. So minus 2x from both sides. And you get negative 3 equals x plus 3. And I'm going to subtract 3 from both sides. You get x equals negative 6. Or negative 6 equals, it doesn't matter. That means that there is only one solution to that problem. For the next one, let's read through it a couple of times probably. The product of a number and 6 subtracted from 8 is negative 10. Now, product, that means multiply. So I know that I'm going to multiply a number. I say let x equal a number. So I'm going to multiply a number and 6. So x and 6 get multiplied and subtracted from 8. Follows from goes first. Whatever follows from goes first. So the 8 is going to go first. It's going to be 8 minus 6 times x. Follows from goes first. Is my equal sign, negative 10. Is negative 10. So I had to switch them because of the word from. When you're subtracting from a number, that number is going to be first. So now I have 8 minus 6x equals negative 10. That minus sign makes the 6x negative. Remember, the number after the sign gets that sign. So that means that 8 is positive. So I'm going to subtract 8 from both sides. Positive 8 minus 8 is 0. The minus sign becomes negative 6x. And negative 10 minus 8 is negative 18. Divide both sides by negative 6. And x equals negative 3. Oh, sorry, positive 3. Negative divided by negative is positive 3. And how many solutions do I have? One solution. All right. We're getting there. Just one page more. You guys stay with me. We've got this. All right. 3 less than. Oh, gosh, it's that then again. Then again switches them. 3 less than is going to switch it. Less than. Less is minus, so we're going to subtract. A number times 5. A number times 5. 5x. And I'm going to subtract 3, because the then switches the number times 5 and the 3. Equal. Sum means add. Of 9 and twice the number. Twice is 2 times the number. So 3 less than the number times 5. Number times 5, 5x minus 3 is equal to 9 plus twice the same number, 2x. Okay, now I have to solve that. Let's see. 2x is smaller than 5x, so I'm going to subtract 2x from both sides. And get 3x minus 3 equals 9. Opposite of minus 3, plus 3 to both sides. And I get 3x equals 12. I'm going to divide both sides by 3. And I get x equals 4. One solution. One solution. All right. Down here, we're going all the way back to the beginning of the school year, where we were doing the different types of numbers. Rational, irrational, whole, integers. There's a lot. So, looking way back, the first thing you should do is try to make each number a fraction. So, change each to a fraction. If possible. If you cannot change it into a fraction, then it is irrational. So let's write that down. If you can't make a fraction, then it's irrational. Remember, you can put whole numbers over 1. So if you have like 7, you can make it a fraction 7 over 1. If you have something like 27, you could make 27 over 1. Negative 3, you could make it negative 3 over 1. All the integers can be put over 1 and then they turn into fractions. But let's take a look at this. 0.39. I got a handy-dandy calculator here. I put 0.39, hit that double arrow key, and makes it the fraction 39 over 100. I'm just going to write that up here. 39 over 100. And now I'm going to do square root of 9. Remember square root. It's the second, and then the green above x squared is the square root button. So second x squared, 9, and I get 3. Ooh, 3 is an integer. I can make that 3 over 1. Ooh, let's look at this negative 13.4. Double arrow, enter, and I get negative 67 over 5. So far, everything here has been rational because I can make them all into fractions. Negative 2, I can make negative 2 over 1. 0, 0 over 1. All the integers can be made into fractions. But now, second, x squared gives me my square root sign, 10. Ooh, that's not a 10, Bono. What did I just do there? 10. And if I try to, it's not going to make it into a fraction. All it does is make it into a terribly long decimal number or back into the square root of 10. That is irrational. I'll put a little I over this one because that is irrational. This one is already a fraction. I don't got to do anything to that. But what about this thing with the repeating decimal? Let's try that. 3.012, 012, 012. I'm just going to put it in as many times as my calculator will let me. And then I'm going to press my double arrow key and look at that. It turns into a fraction, a weird fraction. 1003 over 333. That's kind of an odd fraction, but it's a fraction. Repeating decimals are fractions. They're rational. You can do this. So I'm going to change that right to weird fraction 1003 over 333. Weird, but still a fraction. How about pi? Let's try pi. I have a pi button. Here we go, pi button. Boop. Oh, double arrows? Double arrows again? No. Oh, darn it. Pi is irrational. It's not turning into anything. I'm going to put a little I over that one, too. Okay, identify the irrational numbers. Well, I know I have the square root of 10, and I have pi. Those are my irrational numbers from this list. Identify the whole numbers. Oh, remember when you're going to do a list of numbers, you want it to be a set, so you have to do the curly brackets and the commas. Okay, how do I know something is a whole number? It's all the counting numbers plus 0. So I can count to 3. That means that the square root of 9, whose answer is 3, is a counting number. The square root of 9 is 3. You can count to 3. So that is still a whole number. If the answer is a whole number, the whole thing is a whole number. And let's see, which other one is a whole? Oh, 0 is a whole number. And I think that's it. Rational numbers. All those numbers that we turned into fractions are rational. So, curly bracket, 39 hundredths, and the square root of 9, and negative 13 and 4 tenths, and negative 2, and 0, and 13 over 7, and that weird repeating thing that we had there, 3.012 repeating over the 012. Those are all rational numbers. Integers, what are integers? Integers are all the counting numbers and 0 and the opposites. What do I mean by opposite? I mean the same number but with a negative sign. So, still got that square root of 9. 3 is still a counting number, so the square root of 9 is an integer. Negative 2, that's the opposite of the whole number 2. That's what I mean by opposite. And of course, 0. And those are all the integers. Okay, identify the error and correct it. Okay, we can do that. So let's take a look at this first error. 4 plus 4, negative 2 plus 4. What did they do wrong there? Well, that's a positive 4. If I really want to eliminate that number, I would have to subtract 4. Don't look at anything but the number itself. That should be 4 minus 4, and minus 4 on the opposite side. So 4 should be subtracted. not added. But what else? 4 plus 4, 0, not true. Negative 2x, this should be a negative 2x on this side. And then, wait, negative 2 plus 4 is not, what? Negative 2 plus 4 is 2. But it should be divided by negative 2. And, look, 2 divided by 2 is not 6. So much wrong with this problem. 2 divided by 2 is not equal to 6. It is 1. So much wrong with this problem. You could pick any of those 3 mistakes and it would make me happy. But let's correct it and answer it correctly. First of all, that 4 should be subtract 4 from both sides. And now, the minus sign goes with the 2, so it should be minus 2x, or negative 2x, equals negative 6. Okay, divide both sides by negative 2, and negative divided by negative is positive 1x equals negative 6 divided by negative 2 is positive 3. And that was a lot. There was a lot wrong with that problem. All right, study this paper. A lot of what's on here is on your exam. And good luck. Take care of yourself, and I will see you soon.